The idea that black holes are extraordinarily dense objects is one that I believe is widely held. They did in fact form from extremely dense materials such as collapsing stars. The black hole itself, however, is nothing. 1.5 million kilometers make up our sun. On the other hand, if we were to crush the sun down to even tinier sizes, the sun's whole mass would have to be crushed to less than 6 kilometers across. At that moment, nothing is left behind as the sun's compelled to continue collapsing. It's not a hard surface. It's essentially empty space with no solar stuff present. When you approach a black hole, you might not even be aware that something genuinely awful is going to occur. Therefore, we can conceptualize a black hole as a place rather than an object in a profound way. By day, I work as a physics and astronomy professor at Barnard College of Columbia University. My most recent book is called Black Hole Survival Guide. Would you mind giving the definition of curved space-time a little more time? Just giving it a go here. Thus, space and time's reactions to matter and energy are described by Einstein's equations. Something I toss around the Earth travels in an arc, and if I toss it quickly enough, I can launch it into orbit. Think about the International Space Station, for example. At 17,500 miles per hour, it's flung onto a curve and falls freely. It's really falling free. The motors are off and it's making a beautiful circle. That represents a form found in the Earth's curvature. The curves in space-time are these orbits and these arcs along which objects are falling. Therefore, you could safely approach a black hole and be unaware that something bad was about to happen if you were out in space exploring and you were unaware that you were approaching one. A lens is similar to a black hole. Because of the curvature, you would see the light coming from around the black hole warp. If, however, you discovered after the fact that you were actually close to a black hole and you were desperate to get away, you'd seriously need to replenish your fuel supply. The cost of launching something away from a gravitational object is very high. In addition to being extremely costly, spacecraft launched from Earth demands a massive quantity of energy. There isn't really enough fuel in your spacecraft's tank or thrust from your jetpack that could meet the demands of escape from a black hole, even if you were stupid enough to wander too near. In addition to space being curved, time appears to have been twisted when one approaches a black hole, called time dilation. When compared to someone who's far from the black hole, everything seems to slow down. The time between breaths, thoughts, and clock ticks. The fact that you and your clock are in sync makes your perception of time seem fairly regular. However, your clocks seem to be slowing down to someone who's far away, and it'll seem to someone far away that your clocks have completely stopped ticking as you get closer and closer to the shadow. Additionally, as you traverse and descend deeper into the black hole, the orbits that objects may travel on are progressively smaller. And finally, you'll approach so close that the curves stop abruptly. Nothing. Every path ends inside. This creates a shadow of sorts surrounding the collapsing object, and it's this shadow that establishes the event horizon, or the boundary beyond which light itself can never escape. The fact that you'll be safer for the longest amount of time in a black hole actually increases in size may surprise some individual. It would be possible to pass the event horizon, observe the galaxy changing behind you, jot down notes, compose poetry, and experience a dreadful existential dread. It's possible that you could survive in the largest known black hole for up to a year, provided you had the means to sustain yourself before meeting your demise at the center of the hole. A singularity, or a location in space and time where the curvature is responding to an infinite density, is predicted theoretically based on our explanation of the black hole. At this point, space-time is curving infinitely since all the matter has been crushed so catastrophically. And as you hurtle toward this unavoidable singularity, you'll discover that space is pushing the atoms in your body in the direction of that singularity. It's attempting to separate you as well. The realization that the curvature of space is stronger at your feet than at your head would strike you immediately. It'd feel like your feet were separating from your brain. You'd shatter into pieces eventually. That's why you'd feel like you're being dragged and squeezed. I mean, you're pulverized. Even the atoms are ultimately reduced to their most basic quantum component. Additionally, you'll eventually reach the end as you get closer and closer to the singularity. It would appear as though your quantum particles have completely emerged from the universe and have practically stopped existing if the singularity is real. That whole topic seems to have been lost at the fundamental level. And from the standpoint of a scientist or physicist, that looks not just incorrect, but against some of our fundamental belief, but also metaphysically terrible. We may have to accept that things fall out of the universe and cease to exist if our fundamental beliefs are to be disproved. Or perhaps their ideas are sound and compelling, and we ought to apply them to learn how to alter the ultimate density of matter falling into a black hole. One potentially very important piece of information in the chain connecting the Big Bang to the advent of life on Earth may be black holes. Not only that, but our own Milky Way galaxy's supermassive black hole is in our orbit, and we could end ourselves in a black hole one day. These atoms' ultimate destiny in our solar system may be that. Therefore, I believe it should cause us all to pause and consider the fact that we're all descendants of this universe, that we're all on this rock together, and that we might very well wind up in the black hole's center.